Do you know the best way to solve this equation? If you're starting to plug numbers into the quadratic formula, I want to show you that there's a better way. A way so simple that you may even be able to solve problems like this completely in your head. On the other hand, if you've been struggling to think of the quadratic formula since I brought it up, don't worry, we won't need it at all. We will only need to use some foundations of algebra, which might help you realize exactly what I want all my students to see. Low-key, math is kind of fun. In order to understand what I want to show you today, we're going to build on the skills used to solve problems like these on the screen now. If you're absolutely sure you understand these questions, you can skip ahead to the section of this video labeled The New Stuff. But even if you know how to solve these questions, but not necessarily why you do the specific steps, I'd recommend still sticking around because I may be able to give you some insight as to why the routine steps you know actually work. The first way we learn to solve equations is by canceling. If there's only one variable in the equation, we just use the opposite operation to cancel one thing at a time until the variable is alone. We can change one side of the equation as long as we also change the other side to keep the balance. Let's look at the example 10x plus 15 equals 0. We can see there's only one x, so we know we are canceling, but I know this is a type of problem most people are so familiar with, you probably automatically know to subtract 15 and divide 10 on both sides to get x equals negative 3 over 2 or negative 1.5. However, let's see if you really understand what's going on. Take a look at this problem. Square root of x plus 4 is equal to 3. Even though this looks very different, there is still only one x, so the principle is the same. To get rid of the square root, we want to do the opposite, which would be squaring. Then to get rid of the plus 4, we again want to do the opposite, in this case subtracting 4, to get x equals 5. The second way we learn to solve equations is by factoring. Let's consider a problem where we have multiple x's. X squared plus 10x plus 16 equals 0. If you're thinking about subtracting 16 on both sides to separate our variables and numbers, that totally makes sense and this step is valid. However, we will see there's nowhere to go from here. We can't isolate x when there are multiple of them. So let's go back to the beginning. Our equation equals 0, and there's a very special property about 0 that we learn at a young age. Anything times 0 is 0. Pretend for a moment that I told you I've got two numbers and the product of them is 0. What could the numbers be? It could be 0 and 5, or 0 and 12, or 4 and 0, maybe even 0 and 0, but regardless, one of them has to be 0. So that's all fine and dandy, but what does it have to do with our problem? We don't have two things multiplying to 0, we have three things adding to 0. Well, what if we could rewrite this expression into an equivalent one that was a multiplication? Well, that's called factoring. I'm not going to go into every detail of this at the moment, but for now, I will just remind you that we are looking for two numbers that multiply to 16 and add to 10. In this case, it would be 8 and 2, so we can rewrite this as x plus 8 times x plus 2 equals 0. If you want to understand more exactly how this works, I've included another video in the description, but for the current purposes, I'll just remind that we can multiply this to check it and leave it at that. Well, this rewritten form is exactly what we described earlier. Two things that multiply to 0. Like we showed earlier, one of these numbers must be 0, so either x plus 8 is equal to 0, or x plus 2 is equal to 0. If we look at each of these cases individually, we can see that we now only have one x in each equation and can go back to our first method of canceling to find our two solutions, x equals negative 8 and x equals negative 2. These concepts of canceling and factoring are the foundations for what I want to teach you today. The world of mathematics is constructive, and just like any other construction, it is only as stable as the foundation it is built upon. To test your foundations, try out these problems on the screen now. If you don't feel comfortable with these problems, no worries, but I would highly recommend you check out the video I've linked in the description as I go more into the details before introducing our new concept. Pause the video here and work out all of these questions. Think you've got it? Here are the answers. If you think your foundation could be strengthened, click the video in the description. If you think your foundation is solid, let's build on it. I'll bring back our original problem, x squared plus 10x plus 15 equals 0. Well, we know that we can't cancel with this since there are multiple x's, and we can't factor with this because the only things that multiply to 15 are 5 and 3 and 1 and 15, neither of which adds to 10, so what do? The method for doing this is actually likely not new to you. Most students learn this in Algebra 1, however, the way we traditionally introduce this idea is so confusing that students and even teachers dislike this concept. If you're starting to remember something, I'm going to ask you to ignore it. Trying to remember any steps or formulas you've learned before will only make it that much harder to understand what I want to show you. The way that I explain this to my students is actually to just not explain it. I'm gonna do something very weird, but I just want you to go along with me for a moment. I promise in the end it'll all make sense. I'm gonna add 10 to both sides. I can already hear you asking me, why 10? Remember what I just said. Don't worry about it yet, just trust me. So, if we add 10 to both sides, we would get x squared plus 10x plus 25 equals 10. Do you notice anything about the left-hand side of the equation? Can you think of two numbers that multiply to 25 and add to 10? That's right, 5 and 5. So let's factor this equation to get x plus 5 times x plus 5 equals 10. Normally we get stuck here because this doesn't equal 0, but in this case, is there a more concise way to say x plus 5 times x plus 5? Yes, we can use the square. So finally we have x plus 5 squared equals 10. At this point, how many variables are in the equation? There's only one, so all we have to do is cancel like I showed before. In fact, not only is this similar to the previous problems, if you scroll back, you will see this actually is one of the previous problems. Let's square root to get rid of the square. Don't forget there are two solutions with a plus or minus. And finally subtract 5 to get our final solution. X equals plus or minus the square root of 10 minus 5. Okay, so this worked. Now let's get to the big question. How did it work? If your foundations are solid, every step should make sense, except for one. How did we decide to add 10 to both sides? I want you to think about that. Study this problem and see if you can see why adding 10 worked. Pause the video if you need some time. Think you have an idea? We'll take a look at this problem then. X squared plus 8x plus 3 equals 0. I'll give you some options. Do you think we're going to add 4, 8, 9, 10, 12, or 13? If you're sure you know the answer, congrats, but still see if you can think of why someone might come up with each of the incorrect options. All of these options are things I've seen many students think through, and even if you know the answer, you can learn a lot from trying to understand other people's common mistakes. What if we try adding 10? It worked last time, so it seems at least worth a shot. Well, that makes our equation x squared plus 8x plus 13 equals 10. We actually immediately get stopped here. When we try to factor this, 13 is prime, so the only thing that multiplies to 13 is 1 in 13, and that certainly doesn't add to 8. In our first example, the middle number is 10, so maybe that's how we figured this out. What if we try adding 8? Well, x squared plus 8x plus 11 equals 8 has the same issue since 11 is again prime. So we're left with 4, 9, 12, and 13. Only one of these is correct, but all of the other 3 actually have the same pitfall. If you're thinking of any one of these, you are really close and definitely are on the right line of thinking. You probably noticed that our original equation wasn't factorable, so you wanted to add something to make it factorable. Like, if this number was 12, we know that 6 times 2 is 12 and 6 plus 2 is 8, so that would be nice. So what should we add? We should add 9 to both sides. Now we have x squared plus 8x plus 12 equals 9. Then we can factor x plus 6 times x plus 2 equals 9. However, now we get stuck again. Thinking that we want our equation to be factorable is a great first step, but it's not quite enough. Take a look again at our first example. What do you notice about the factors? They were the same. They were both 5, which is what allowed us to combine together our factors into the square, which then allowed us to cancel. So, which of these numbers is going to do that? We need our factors to add to 8, and they need to be the same, so that means it has to be 4 and 4. So it needs to multiply to 16, so how do we get from 3 to 16? By adding 13. Now, if we just finish this problem up by factoring and canceling, we can get our answers. X equals plus or minus the square root of 13 minus 4. Hopefully, you're starting to understand the concept now. See if you can solve these. What number do we need to add in each of these problems? In the first one, we've got to add 13, and in the second one, we have to add 2. From here, we just complete the problems to get our final answers. X equals plus or minus the square root of 13 minus 5, and x equals plus or minus the square root of 2 minus 3. As I've mentioned, every step beyond this first one is just factoring and canceling. If you're getting a little lost in these steps, it's probably a sign that your foundation needs to be strengthened a little more before trying this topic. Like I mentioned earlier, I've got a video in the description that will help you understand these steps that I'd recommend you switch over to now. If you're hesitant to switch videos, I will tell you the same thing I tell my students. First, random fun fact you need to know about me. I like to juggle. I got into it in college, and it's just a really fun thing to do with friends and a nice way to enjoy the fresh air outside. Anyways, when my students try to move through a topic too quickly, I'll ask them, does it make sense to try to learn to juggle 5 balls if you can't juggle 3? Of course not. You have to learn to juggle 3 before trying 5, and math is exactly like this. Trying to move on before you set your foundation will lead at best to a mediocre construction that is almost sure to have major issues in the future. Don't worry, you'll be back and I'll be right here waiting for you. Let's move on to 2 more problems. Are you starting to see how you could do this in your head? If not, no worries at all, but the basic idea just comes to realizing that the numbers don't really change much as we go through all of our steps. Our magic number we add kind of just stays there, and the other number only changes when we cancel it out. Here are 2 more questions. If you want to write it out, no worries, but if you think you're really getting this idea, try to do these in your head. Here's 2 final questions that will push your understanding a little bit this time. I'd recommend writing these out even if you did the last ones in your head. Take a stab at them. The first problem has a big common error, but if you try to do it, you'll see where you get stuck and actually learn why that error is an error. You learn from mistakes, so don't be afraid to make them. The common misconception with the first one is to subtract 13. Since it's negative, it seems reasonable to assume we would want this to be negative, but if we actually do it, we will get stuck once we try to factor because negative 4 times negative 4 is positive 16, not negative 16. So even though we see negative signs, we still want our magic number to bring us back to positive 16. So we actually need to add 19. In the second problem, because the number we want to add is odd, that means we're going to have to work with some decimals, but the concept doesn't change. It needs to add to 5, so that means it's 2.5. 2.5 times 2.5 is 6.25, which means we need to add 4.25, and then proceed like normal to get our final solutions. Nice work. Thanks for sticking with me. Hopefully I was able to teach you something kind of new, but before I end this video, there is a slightly bigger point I want to make about learning mathematics as a whole. This method of solving is known as completing the square. If that name sounds familiar, like I said, this is usually taught in a standard Algebra 1 course. However, it is usually presented as a series of steps that, without any explanation, are very random and confusing to most students before quickly moving on to the quadratic formula. Don't get me wrong, the formula 100% stands in its own right, but I think we focus too much in math class on finding solutions. That may sound bizarre to criticize, but I think it's really important. I want to encourage everyone to teach and learn math not for solutions, but for understanding. Number 1, just in the world of math, understanding allows you to build to other concepts. From completing the square, we can very naturally see where complex numbers come into quadratics. We can use it to analyze equations graphically, and can even use it to derive the quadratic formula itself. Even years later, in Calc 4, my understanding of completing the square made it a lot easier for me to learn integrating factors, a topic many of my peers struggled with. The method itself is not directly used, but just the way of thinking in completing the square helped integrating factors just make a lot more sense. Number 2. In the real world, when was the last time most people had to solve a quadratic equation? Understanding completing the square lets us see how the counterintuitive can be 100% right, and the world is filled with counterintuitive things. When you get a bug bite, the best thing to do, despite all your urges, is to not scratch it. One of the most important techniques for controlling wildfires is to start more controlled fires. Speaking of fire, we normally think of water as being the opposite to fire, but an oil or electric fire should never be put out with water. If you're driving on an icy road and your front tires begin to slip, you need to steer the direction you're slipping instead of trying to stop or correct it. Counterintuitive things like these and so many more are difficult for us as humans to accept at times, and in many cases, that can be incredibly dangerous. Trying to understand topics like completing the square allows us to critically analyze how a counterintuitive idea in general can actually make total sense, and hopefully encourages us to be open-minded and creative in every situation we face. Number 3, let's set aside real-world application entirely. What's more interesting? Plugging in a bunch of numbers or solving a puzzle? Again, the quadratic formula definitely has its uses, but completing the square is so fascinating, creative, and elegant, it has the potential to just innately be enjoyable. It's like a game. It even has its own progression of levels that get more and more difficult. I've seen so many students enjoy it. It's so much fun for me to teach it because it's fun for them to learn it. This topic, more than any other I've taught, gets students to see how interesting mathematics really can be. So much so that time and time again, it gets my students to say some of the best words a math teacher can hear. Low-key, math is kind of fun. Thanks for taking the time to watch this video. This is my first video, but I'm kind of thinking about trying to make this a full channel. YouTube was pivotal to the development of my own passion for mathematics, and I hope to pass that rod on. I want to share the beauty behind the typical concepts you learn in high school. I hope to help people not just succeed in their math classes, but to appreciate and maybe even enjoy learning it. Regardless, thanks so much for watching this video. If you have any questions or comments, I'm more than happy to try and address anything you drop below. Thanks to all my friends who helped review this video or just supported me in general, to my students for making me the teacher I am today, and all the teachers and channels that have inspired me so far.